Okay, I'm going to explain how to do the homework, and you can always refer back to your notes that we wrote today. It's either page 30 or 31 in your notes, and basically it's correcting scientific notation or putting it into scientific notation. So write the following numbers in scientific notation. So for example, number 1, this decimal needs to move 2 to the right. So when you move it 2 to the right, the number's getting bigger and bigger, but you've got to subtract 2 from the exponent to balance it back out. So this number here and this number here should be opposites of each other. So it becomes 5 times 10 to the first power. Now number 2, it's already in scientific notation. So I'm just going to write that. Okay, number 3. I have to move the decimal 1, 2, 3 to the right, which is a positive 3. You got to do the opposite to the exponent, so it becomes 3.88 times 10 to the third power. This one you have to go left 1 for number 4, so subtract 1, you add 1 here. So it becomes 3.88 times 10, and negative 6 plus 1, double check your work, it's not a 7, it's not a negative 7, it's a negative 5, so be careful about those signs. Here, number 5, there is no times 10, so we're going to put times 10 to the 0. And the decimal, if it's not visible, it's on the far right, so we're going to go left 2. Left gets negative. The opposite of negative 2 is to add 2 to balance it out. So you get negative 2. You can put 0.00 if you want, times 10 to the positive second power. Number 6. The decimal is to the far right if you don't see it, so it has to go left 1, 2, 3. To be in correct scientific notation. So since I'm going negative 3 here, I'm going to add 3 here. So it becomes negative, don't forget about the negative, 3.889 times 10 to the first power. Number 7, okay, if it helps you to rewrite it without the commas, okay, so 588 and then 1, 2, 3, 4 zeros, okay, the decimal's here. And by the way, since there's no 10 to the a power, it's 10 to the 0 power, so okay, so I have to go back 1, 2, 3, 4, 5, 6, which means I need to add 6 here. So it becomes 5.88 times 10 to the 6th power. Okay, for this one, you got to go right. So 1, 2, 3, times 10 to the 0 power. So you have to go 1, 2, 3, 4, 5, 6, 7 to the right and subtract 7 from the exponent. So it becomes 5.88 times 10 to the 0 minus 7 is negative 7. Okay, now number 9 also doesn't have times 10 to the 0, so we're going to go ahead and write that in. And don't forget there's a negative, but you have to go 1, 2, 3 to the right for the decimal to be in the correct place, so you subtract 3 from the exponent. So it's negative 4 times 10 to the negative third power. Number 10, the decimal just needs to go 1 over to the right. You're adding 1, so you subtract 1 from the exponent. Don't forget this negative. Negative 4 times 10 to the third power. Number 11, so here the decimal's on the far right. You have to go left 2, so you got to add 2 to the exponent. Remember they're opposites, so it's 2.10 times 10 to the 7th. And for this one, you got to go 1, 2 to the right, so subtract 2 from the exponent. Don't forget it's a negative, so negative 7.17 times 10 to the negative second power. And number 13, I'm going to add the times 10 to the 0. The decimals here, go left 2, so you add 2. So it's 9.17 times 10 to the second power. And then also here times 10 to the 0. So I have to go 1, 2, 3, 4, 5 to the right and subtract 5 from the exponent. So it becomes 7 times 10 to the negative 5th power. Okay, now this bottom part says show that 2.56 times 10 to the 5th is equal to 25.6 times 10 to the 4th, which is equivalent to 256 times 10 to the 3rd. Which one is in true scientific notation? Explain. So the way we're going to show that 2.56 times 10 to the 5th is equivalent to 25.6 times 10 to the 4th and 256 times 10 to the 3rd, I will, instead of I, convert each number into standard notation. So 2.56 times 10 to the 5th, you would take 2.56 and you go 1, 2, 3, 4, 5, add 3 zeros, and it becomes 256,000, okay? And if you take 25.6 times 10 to the 4th, I'm just going to write this, 25.6, you have to go right 4, 1, 2, 3, 4, add 3 zeros, alright, so then you have 256, 1, 2, 3 zeros, okay? And if you have 256 times 10 to the 3rd to begin with, well, 256 has a decimal here, and you got to go 3 to the right, so 1, 2, 3, you're adding 3 zeros, so 256,000. So they're all the same. Each number converts to 256,000 when in standard notation. Oops. All right. 2.56 times 10 to the 5th is the only one in scientific, I should say true, scientific notation. And the reason I'm writing in pen is because the pencil seems to have it reflect off the paper, so I'm using pen, and otherwise I would have erased that. So is the only one in true scientific notation because the number to the left of the decimal is between 1 and 9. And that would be it.